Hey, in this tutorial we will cover the constants that are built into EES, how to create your own constant if it is not included among the list of the constants built in. We'll talk about creating comments in the equations window to make this more readable and more understandable to someone who will pick it up later on. We will talk about, in printing to a PDF file, the different options that are available to us there, and presenting the solutions in a logical and straightforward manner that makes it much easier for, again, someone to pick it up and make sense of it. So to look at the constants, we will look in the options constants window that pops up. These are all the constants built into EES. There's a few dozen of them here. Some of them, most of them are familiar, maybe some of them are unfamiliar too, but for instance we have the gas constant. This is a value of 8.314. Here are the units of that, kilojoules per kilomole K. Planck's constant, to draw your attention to another one, and many other such constants. But you'll see that each one of these, the first column is the name, and this ends in a pound sign, and that's always going to be the case. And that's the indicator to EES to know that you're trying to extract the value for that constant. So for Planck's constant, for instance, I can still have a variable in my workspace by the name of h. I just don't include the pound sign, and I'm not rewriting over anything. What we're going to do in this example is make use of the gravitational constant at sea level. It is right here. Gravitational acceleration at sea level, 9.807. The units here are meters per second squared. So I can just double click this, I can hit paste. Both of those will just end up putting this into my equations window, but that's literally all it is just the variable followed by a pound sign. And so I could just simply type that in, and I can name it something. In this case I'm going to name it G as well. So I've got units there, pulling that number like I said. If I have different units, you'll see if I open up my preferences and I say never mind, I want to use English units, and I hit OK, I rerun this and it automatically changes to feet per second squared. And you'll see in the constants window that value, gravitational acceleration at sea level, is updated in the units consistent with the preferred unit system that you have already defined. I'm going to take this back to SI units, and just another quick interesting thing, if you look through this list and you don't have the number that you want, the constant that you want, so perhaps you're going to do some work doing some analysis for something that's going to be on Mars, and so the gravitational constant on Mars is not something that is built in, so I add, and I will call this G Mars, and I have to add a pound sign afterwards, and I give it a description: gravitational acceleration on Mars, and the value for this is 3.721, and the units for that's going to be meters per second squared. And now I either need to convert it and list the value here, or I just need to tell it what units I want it to be when dealing in English. And the easiest thing to do is just type. You can just hit OK at this point, or you can hit convert, and it tells you what that. This is going to be 12.2 feet per second squared. I hit OK, and you watch this paste button is now modified to a store. And so if I want to store this in the constants.txt file that I'll have available to me every time I open EES, then I would hit store. And for this one, let's go ahead and do that. And so I can close EES and open it back up, and I'll still have that G underscore Mars. And there it is, 3.721. And so I could use that in any of the calculations I'm going to do. So let's do a quick sample problem. For this one, let's look at the problem statement. So we have an object with a mass on Mars of 4 kilograms. And so I'll go ahead and type the mass in here. That's a given piece of information. I've got kinetic energy of 15 kilojoules. That's given. And then I have an elevation, we'll call that y, equals 3.5 meters. And the question is, what is the total energy? I want to add the kinetic and potential energy. So let's first just calculate the potential energy. I'm going to need to get that G like I've done here, and then I need my potential energy is going to be mass times G times my height, which is Y. So let's go ahead and hit the calculate button. This error here is it's trying to interpret this as a function, and so one of the things you'll want to do in a good script or a good set of equations is comment this up. And so how do I do that? If I have an entire paragraph or a section that I want to comment out, I can do that with a quote at the beginning and a quote at the end. And now you see that that turns blue, and that helps us with the readability later on. Okay, so we've got a unit problem here. So let's go to potential energy. We haven't told it what units to use. All the other ones we've specified. And so if I look at this, I've got potential energy as a mass times gravitational acceleration, so kilograms times meters per second squared. That gives me a Newton times some elevation. So y is in meters. So a Newton times a meter, that's going to give me a joule. And so if I come in here and type joule, that is indeed correct, because my calculations, the numbers I use, should turn out to be a joule. But now when I go to get my total energy, I just want to add those two together. I'm going to have a problem, and it doesn't matter if I say joules or kilojoules on this one. It's not going to work out, because the two terms that I use to calculate my total energy, one of them's joules, one of them's kilojoules, and so we need to change one of them. And I find myself using the kilojoules a lot more often, so all you have to do is come in here and convert this from kilojoules or from joules to kilojoules. And once I do that, my unit problems should go away, but I need to come in here and also type kilojoules there. So now my potential energy is expressed in kilojoules. My kinetic energy was given in kilojoules, and so my total energy is also in kilojoules. Okay, so that's one way to comment in here. The other way is to, if you just need a line, then you just put double hash, and then you can write something. So this is the given information, and maybe I want to say grab the gravitational constant for Mars, and this line would be calculate potential energy, and then I am going to add potential and kinetic energies together. Okay, and then when I hit the calculate button, those are all comments, and so they turn blue within the equations window. And I've got my solutions here. I've got no unit problems. I'm ready to go. So if I come up here to the print icon, then you'll see I have a number of options available to me. I got my equations, the solution that's just going to print those windows as I see them. And then there's this other one, formatted equation. Let me show you what those are. If I come to my formatted equations window, this is a way to really troubleshoot the equations that you're inputting in the equations window. So a lot of times you're trying to line up parentheses, you're trying to figure out what's on the numerator, what's on the denominator, what's in the square roots, what's in the brackets, etc. This is as you would see it on a piece of paper, and so that enables us to troubleshoot a little bit better. So I typically don't include this in my PDF printout, but I do use it in my troubleshooting to try to figure out if I did indeed write that equation correctly. But I can print that out, and if I go to now print this out, I have equations, I got formatted equations and solutions, and I'll go ahead and print that out. And the PDF that results will have a section here that is my equations window, a section here that is my formatted equations window, and then finally, do it this way, and then finally my solutions window. And it tells me with those solutions I didn't have any unit problems. And so another thing I can do is come in here, and let's say that I have many more variables and they're all going to show up in the solutions window, and I just want to highlight a couple. And so I can do one of two things, or do them together. Say that energy is the final answer, and so I can highlight it either with underlining it, making it bold, put a box around it. I can make the text a different color, so maybe I make the text red, and as I hit OK, then this shows up in a different font color. It's got a box around it. It's easy for me to see. The other thing I can do is right click on this and then make it what's called a key variable, and I say maybe this is a total energy, and you'll see a new tab popped up here, key variables, and I've got my comment right next to it there. And the nice thing about this is when you get extremely long scripts, every variable is going to show up here. It's going to be in alphabetical order, so it's kind of hard to know exactly what you're trying to highlight, even if you put boxes around them. But if you take those two or three things and make them all key variables, then they show up separately in this dialog. And even in the PDF printout, it'll show up in a separate section. So let's say that this was also a key variable for me. This is my potential energy. And you go with the key variable. I've got these listed both here. And the other nice thing of this is I can change the order, and I can move them around to do whatever I want to there. And so now when I come and print this out, let's get rid of the formatted equations. Let's just print the solutions in the equations window. And the result is the equations window. So I got my problem statement up here, my equations window, and then my solutions followed by the key variables. And I can even suppress the solutions window if I want to. If I come in here to my PDF and I unselect that, and it asks me which ones do you want to print from this. And especially if I have a huge script, maybe it's not useful for me to do the main solutions window, just the key variables. And so you see how this is a shadow now, so it's part of the solution that it's printing out. But you can play around with this. Once we get to plots, then you'll be able to select which plots to print if you have multiple plots, tables that we'll talk about in a future video. And that concludes this tutorial. Thank you.